Welcome! In this technical explainer, we're going to dive deep into the high availability features inside Cisco's SDA Wireless architecture. Look, if you've ever had to deal with a network outage, you know the pain, the angry calls, the lost productivity, all of it. So today, we're going to show you how to build a wireless network that's not just fast, but pretty much bulletproof.
All right, here's our game plan. First, we'll quickly cover why high availability is so important in the first place. Then, we'll break down the 3 core pillars that make it happen. The redundant control plane, that's the brains of the operation. Stateful switchover for the controllers, which are the heart of the network, in a really smart way to upgrade access points without any downtime. Finally, we'll pull it all together and see how it creates one incredibly resilient wireless network.
So let's just start with the why. You know, in today's world, wireless isn't just a nice to have, right? It's how business gets done. When it goes down, it's a massive problem. I mean, think about it. A dropped call with a client, a failed transaction at a store, a doctor who can't get patient records. That's why high availability, or HA, isn't a luxury. It's absolutely critical. It's all about designing a network that can handle failures gracefully so your business doesn't have to.
You see, in the world of SDA Wireless, resiliency isn't some feature you bolt on at the end. It's baked right into the architecture from the very beginning. And it's all built on these 3 powerful pillars, each one designed to tackle a different potential point of failure. When you put them together, you get a system that is way more robust. So let's jump in and explore each one. Okay, let's kick things off with our first pillar, the redundant control plane. Now, you could argue this is the single most important part of the entire SD-Access fabric. You can think of it as the network's central nervous system. It's making all the smart decisions about where data needs to go. If the control plane goes down, the entire network is basically flying blind. So let's see how SD-Access protects this vital function.
So what exactly is this control plane node? Well, at its core, it's just a huge database that keeps track of every single device on your network. It knows which user or device, the endpoint ID, is connected to which network switch, or edge node. It does this using a protocol called LISP, which stands for Locator/ID Separation Protocol. Honestly, the easiest way to think about it is like a DNS for your local network. It maps a device's permanent identity to its current physical location. This is what lets you roam around seamlessly. In this diagram right here really makes that concept of active-active redundancy crystal clear. Let's walk through it. Up top, you've got your wireless LAN controller. It's getting updates from the APs as new clients connect. But here's the magic part. Notice it's sending those updates to both control plane nodes at the exact same time. There's no primary, no backup. Both nodes are live, active, and perfectly in sync. This is a huge deal because it completely eliminates the control plane as a single point of failure. And here's a peek behind the curtain at how you actually set this up. This is a screenshot from a controller, and as you can see, it's ridiculously simple. You just plug in the IP addresses for your primary and secondary control plane nodes, and that's it. This one simple step enables that powerful active-active architecture we were just talking about. It's a perfect example of SD-Access taking something really complex and making it easy to deploy. So what's the bottom line? In a word, seamless. Because both nodes have the exact same information all the time, if one of them fails, maybe a power outage, maybe a hardware failure, the network doesn't even blink. The controllers and switches just keep talking to the node that's still online. It's like having a co-pilot who can instantly take the controls, and the passengers don't even know it happened. Okay, so we've protected the network's brain. Now let's talk about its heart, the wireless LAN controllers. These are the devices managing all your access points, handling client authentication, enforcing policies. They are the real workhorses, and if one of them goes down, hundreds, maybe thousands of users could lose their connection. To prevent that, we use a feature called stateful switchover. Stateful switchover, or SSO, is the technology that keeps your wireless clients connected even if a physical controller completely fails. It works by having a standby controller in a hot standby mode, constantly getting synchronized by the active one. The key word here is stateful. That means it has a complete, real-time copy of all the client session info, their authentication status, security keys, quality of service policies, all of it. That's what makes the failover so smooth. This slide shows us what the system looks like during normal operation. You can see the SSO pair, one active WLC and one standby. Now, it's really important to notice that only the active controller is talking to the control plane. This is to make sure there are no conflicts in the fabric. But in the background, that active controller is constantly feeding all its state information over to the standby unit, making sure it is ready to take over at a moment's notice.
And here's the failover in action. Let's say the active WLC goes offline. Instantly, the standby unit flips to become the new active controller. The very first thing it does is perform what's called a bulk update to the control plane. It's basically announcing to the whole network, hey, I'm in charge now, and here's a full list of all the clients I'm handling. This whole process is incredibly fast. For the APs and the clients, it's completely seamless. No dropped connections, no re-authenticating, it just keeps on working.
So the result here is incredibly powerful. You get zero downtime for your users, and it's actually easier to manage because Cisco DNA Center sees that SSO pair is just one single device. But, and this is important, you have to be aware of the design limitations. In SD Access Fabric mode, you have to use this one-to-one SSO pairing. The older N+1 model, where you have one standby backing up a bunch of active controllers, that's not supported here. It's just something you have to keep in mind when you're designing your network.
All right, so we've talked about unplanned outages, but what about the planned ones? I'm talking about scheduled maintenance, especially software upgrades. Historically, this has been a huge headache, right? It usually means a late-night maintenance window and hoping for the best. Well, with SD Access, there is a much, much better way. Let's look at our third pillar, rolling AP upgrades.
Now, this diagram might look a little busy at first, but the idea behind it is actually pretty simple. This shows an N+1 design, where every access point can connect to more than one Catalyst 9800 controller. This physical redundancy is what makes rolling upgrades possible. Because every AP has a backup path, we can take one of the controllers offline for an upgrade without punching any holes in our wireless coverage.
Now this is where it gets really cool. This whole process is almost completely automated. Using radio resource management, the system intelligently groups nearby access points together by figuring out which APs can hear each other. Then, from Cisco DNA Center, you just push the upgrade. The system upgrades one group at a time, making sure neighboring APs stay online to provide coverage. It's a zero-touch, hitless upgrade. This is a total game changer for network admins. No more late nights, no more user complaints.
So we've gone through all three pillars of SD Access wireless resiliency one by one. Now let's just zoom out for a second and see how they all work together to create this unified, resilient network. It's not about any single feature. It's about how they combine to create something that's way stronger than the sum of its parts.
So as you've seen, SD Access builds resiliency at every single critical layer. We have that active-active protection for the control plane, the network's brain. We have stateful, hot standby protection for the controllers that are managing all the traffic. And we have an intelligent, automated way to maintain the devices at the edge, the access points, without disrupting service. It really is a comprehensive defense-in-depth approach to high availability. You know, this whole multi-layered approach to HA really forces us to rethink how we design wireless networks. It's a big shift, moving from a reactive model, where we're just scrambling to fix things when they break, to a proactive model, where we build the network to be resilient from the very start. It's about moving from just providing connectivity to guaranteeing business continuity. So, the question I'll leave you with is this. How can you apply these principles to make your own network more resilient, more reliable, and ultimately more valuable to your organization? Thanks for joining me for this explainer.